welcome you to our first session. This will be this is a series. It's a modern data warehouse series with Nilesh Gule. The first part will be overview of modern data warehouse and Azure services. Nilesh Gule is actually a Microsoft MVP for Azure. He's also the organizer and he handles the Azure group for Singapore. So with that, I'll hand it over to Nilesh.
Thanks, Pio. Are you able to see my screen?
Yeah, we can.
Okay. Hi, everyone. Thanks, Pio, for introducing me. In case you don't know me, I'm Nilesh Gule, and I come from Goa. So I like to call this place like the Phuket of India. If you come from India, Goa is like very famous for its beaches, and the Bollywood movies shows Goa as the most happening place in India. So I come from this wonderful land, and these are my social media contacts if you want to contact me. I'm also the co-organizer of Azure Singapore, and we have a huge lineup of upcoming events. When I'm not talking about technology, I like to watch the game of cricket. And if somebody wants to talk about cricket to me, I'm also happy to discuss about the retirement of MS Dhoni and Suresh Raina and the future of Indian cricket, if you are really interested. Over the last few months, since we are all working from home because of this COVID situation, I've also been able to clear some of the Microsoft certifications, and you can see some of the certifications that I managed to clear over the last 3 or 4 months. I'm also sharing some of my learning about these on my YouTube channel, so feel free to have a look around those. Now, coming back to today's session, we'll be talking about the modern data warehouse and building that using cloud and specifically Microsoft Azure. So the overall agenda for the 3-part series involves looking at all the components of the modern data warehouse. We look at data lake architecture, and then we go into the demos related to specific services which we'll be using. So we start with the storage account and Azure Data Lake Storage. Then we move on to Data Factory. We will also look at Databricks, Azure Synapse, Azure Key Vault, and some of these cross-cutting services which come across. So let's start by looking at what are the components of modern data warehouse. Data warehouse in general has been there for quite a long time. But if we look at the current situation, we see that the size and the shape of the data warehouses, they are changing quite a lot since the advent of cloud. So if you look at, let's say, the history of modern data warehouse or the way we were doing data warehousing about 10 years back, things have shifted to cloud quite a lot in recent times. And that has also made us to change the way we look at the data warehousing in general. One of the things which has changed quite a lot is the kind of data that we are dealing with. So if you look previously, most of the data that was stored in data warehouse was structured data. We had very well-defined tables. We had schemas like star schemas, snowflake schemas. These were very well understood concepts. But with the cloud, main thing that has changed is the way we store data. Storage has become quite cheap, and the processing compute is also becoming relatively cheaper. So now we have this huge petabyte scale storage available to us. We also have compute which is available on demand. And then because of things like the HDFS or Hadoop, we have this separation in the way we store data and we use compute. So there is clearly a distinction between the storage and the compute areas. So in this diagram, if you look, we have data which is coming from multiple sources. So we have the on-premise traditional data sources like your RDBMS, Teradata, file shares, SAP, Oracle, SQL, all the things that we have been working, I think, for decades. Then we have the cloud data sources. So things which are developed purely in cloud, things like Azure Services, AWS, Google Cloud Platform, and various other cloud providers. And there is also this new breed of software, the SaaS data, which is coming from the SaaS data sources. So these are the different data sources which we ingest, and data ingestion again is an area which has changed quite a lot. In the past, we would use what is called as the extract, transform, and load process, or ETL. This is again very well integrated into the tools which are currently available in the market. But with big data technologies and the cloud, there is a slight shift in the way we deal with data. I'm pretty sure you all know about the 6 or 7 different V's of big data: the volume, variety, veracity, all those things. So with that, the way we deal with data is, instead of doing the transformation in the source, what we tend to do is we bring in all the data as is, and we don't really enforce schema at the time of bringing in the data. We bring in the data in its raw form, and the data ingestion happens, and the ETL changes to ELT. So we extract data, we load the data, and then we transform it only at the time of when we have to make use of that data. So what this allows us to do is to address different kind of use cases. So you might have, let's say, a normal traditional data warehousing process, which goes through these different phases like ingestion, preparation of the data, transformation, enrichment, and then serving this data onto the visualization tools. It also allows us to address additional and modern techniques or tools, like the same data which is ingested can be used for things like machine learning. We can run AI models on top of that data. So with that, it allows us to address multiple use cases using the same set of data or similar data. Now, apart from ingestion, in terms of preparing the data, so once we have loaded all the data that we need, the other thing which is regarding ingestion is when we look at data lake in general, we also have different types of data. So as I said, historically, the data warehouses were mainly relational data and very well structured data. But in the data lake, we can have any kind of data. We can have semi-structured data like JSON files or XML files. We can have unstructured data. We can have video. We can have media files. We can have audio files, things like that, which are completely dynamic in nature. We can have images, and all this can be stored in the data lake. And once we have this data, then we use different tools to prepare the data that is required for our analysis. So when it comes to Azure as such, we use multiple tools here or multiple services. Azure Data Factory is one of the service which is used. And in today's session, I will be covering in depth the Azure Data Factory as well as Azure Data Lake Storage. Then if we are looking at open source kind of tooling, Azure Databricks is quite popular. It is a Spark as a service offering, and it works on in-memory data structures. It allows us to process data in very efficient manner. When it comes to transformation and enrichment, again, we can use features of Azure Data Factory or Azure Databricks, and for the serving purpose. So once the data is analyzed, or once it is in a good shape, once we have enriched the data, once we have built the kind of data which is required in a presentable format, which is required for visualization tools like Power BI, Click, or Tableau, we can serve that using Azure SQL Data Warehouse. And underlying all this is the storage layer. So if you have used other cloud providers like Amazon AWS, the Azure Data Lake Storage is similar to your S3, and that forms the base across all these different services, or it gets used across these different services. So it's very difficult to cover all these different components in 1 hour or let's say 90 minutes. That's why when me and Pio started discussing about this sessions, I proposed to split this into 3 parts. Today's session, the part 1, we will be focusing on the data lake storage and Azure Data Factory. In part 2, we'll be talking about Azure Databricks and Azure Key Vault. And part 3, we will focus our energy on Azure Synapse. So let's spend some time looking at the data lake. As I said, a data lake can contain any kind of data. And if you don't manage that data well, your data lake can become what is generally called as data swamp. So you can put any kind of data, and if you allow people to put each and every kind of data that's available in the whole universe, then you can easily mess around with the complete structure of the data. That's why there is this very good article on DZone about how to govern the data lake. And if you look at this diagram, what it proposes is to zone your data into data lake into multiple zones. So we start with the data element, which is the source data or the types of data, which is coming in from all these different sources. It can be file data, it can be relational data, it can be streaming data. So again, when it comes to the volume of data, nowadays we are all connected, whether we like it or not. We have petabytes of data being generated every day. We all use smartphones. We all have these smart gadgets, which all generate large quantities of data. So all that can be landed in what is called as a transient zone. And this is where we start ingesting the data. We start tagging the data. We build a catalog of data, and then we move this data into a raw zone. In this phase, we apply metadata. We look at some of the sensitive attributes. If we have to do filtering, or if we have to do some masking, anything related to sensitive data handling can be handled in the raw zone. And then we build the data quality and validation. That is the output which goes into your trusted zone. And once we have the data which can be trusted, once it has passed all the data quality, it has passed all the validations, we can use it to enrich and automate the workflows. And this data then gets stored in the refined zone. And finally, this data gets used by the enriched data, or the data which is very well prepared, is available for data visualization, and the downstream systems, the consumer systems, can use this data. With that, let's start into the services, and let's get into the demo mode. I think that's the last part of the slides I would have, other than the summary slide. I hope that you know a bit about Microsoft Azure and the services. This is the Azure portal where you can log in and you can start creating the services. First thing that we will look at is the data lake storage. Data lake storage is Hadoop compatible, and it gives us petabyte scale capabilities. So to create a storage account, I can go into create new, and I can click on the storage account. When I click on create, we will be asked the standard questions about what is the resource group where I want to create, which subscription I want to use, the name of the storage account, location. So let me give some basic information here. I have actually created these services, but just to show you the process, I will quickly walk you through. So we create a new resource group. So if you don't know what is a resource group, it's a logical collection of different services which can be grouped together by, let's say, a project or by a team. And then we give a storage account name. So this has to be unique. Then we can choose the location where I want to create this storage account. So I need this in the Southeast Asia. I see slight change in the naming locations here. Then the performance part. So we can choose either standard or premium. If we choose standard, we will get the normal HDDs based storage. If it's premium, it's the SSD based. And then we have the kind of storage account. So the most recent version is what is called as the general purpose V2 storage account. And we have the blob storage and the general purpose V1 storage account available. In most cases, we should choose storage account V2, which has all the performance enhancements and the latest and the greatest features associated. Then we look at the different modes of replication. We can store data or we can replicate data across different tiers, different zones, and there are currently these options available. So let me choose the least possible, or the one which is the easiest one, which is locally redundant storage, which creates 3 copies of my data within the same data center. Zone redundant is it will create multiple copies within the same zone across multiple data centers. Geo redundant, I can choose to have a copy of my data across geographic location. And then the remaining 3 are extensions or combinations of these 2, the geo redundant and read access, and also the zone redundant part. So for simplicity, I will choose the locally redundant. And then we have the access tier. Access tier allows us to classify the data or to have SLAs based on how fast we want to access the data. So our pricing of the storage account varies based on whether it's hot or cool tier. So hot means we'll be accessing the data quite frequently, and cool tier can be used for less frequently accessed data. There is also an archive tier, which is not available in the UI, but we can specify using other tools like the Storage Explorer that a particular storage account's data needs to be stored for long-term archival purposes. Once we have all this basic information, the next thing is networking. And how do we connect to this particular storage account? We can have this accessible over the public network. We can choose to have this accessible only over a selected networks, or we can have it accessible via a private endpoint. If you are having, let's say, an organization account and you want to restrict the access to who can access your storage account, it would be most likely that you make this as private and you restrict the access from where the storage account can be accessed. And there is also the routing preferences, whether you want to use Microsoft Network or you want to go over the internet and access the storage account using internet routing. Then the next one is regarding data protection, whether you want recovery for the blobs. If you want to enable soft delete, that means if you delete, the blob would not be deleted immediately, or you can still recover within a specified period of time. Then there are other options like for tracking, which you can select based on your preference. And then the security part, the advanced settings. So this is related to how do you want to connect to the storage account and whether you want to have SSL, whether you want to have secure transfer, whether you want to allow public access to your blobs. So now I'm allowing these, but based on, again, your company policies or your preference, you can change these individual settings. The last but not the least is this part, the hierarchical namespace. This is very important to understand because this is a feature which is something which is unique to the data lake storage Gen 2. And when we say we want to enable hierarchical namespace, if you look at the normal object storage in cloud, you don't really have a hierarchy. You get a blob and that is logically divided into like a hierarchy. It's all a flat hierarchy. But when you enable the hierarchical namespace, it allows us to create like files, folders, and directories, subdirectories inside that. And this helps in the performance as well. So most of the people, when they start looking at Data Lake Gen 2, they try to say, OK, home, create new, and they search for Data Lake Gen 2 account. There is no privilege or there is no provision in the portal to create a Data Lake Gen 2 account directly. It's just a feature of your normal storage account, which you need to enable. And once you have enabled that, the last part is you can specify some tags. It's always better to have tags like who is the owner of this particular storage account, which team is maintaining it, which billing unit is responsible for this storage account and things like that. So once you have given all this, it takes about a couple of minutes to provision the storage account. So I have already gone ahead and created a storage account for today's session. Let me go and have a look at that. So when you look at this particular storage account, with most of the Azure services, you have two panes. Like one is your the management pane, and then you have the data pane. So this is the management pane where you can have access to all the management features. We get all those summary of whatever we selected at the time of creation of the storage account. And if you look here in this area, you see that there are multiple sub-services or multiple services within the storage account. So it's not like when we create a storage account, we get only storage. We have something called as containers, which are similar to blobs in the version 1 of the storage account. Then we also have file shares. So if you want like a SMB serverless file share, we can choose a file share. There is also tabular data storage if we want a very simple key value pair, NoSQL kind of database tables, we can use tables. And there is also queues, which is used for simple like first in, first out queuing mechanism. And all these services, they can be accessed using the tools as well as SDKs. So you have Storage Explorer, you have PowerShell, Azure CLI, .NET, Java, Python, and Node SDKs. Using any of this, you can interact with these services. We can also have, from a security point of view, different role assignments. So if you're aware of the Azure Active Directory, it provides default roles. And here we can go and say, add a role assignment, and there could be different kinds of roles. So we can have like contributor, reader, specific to the storage account itself. We have roles for like a storage blob data contributor. We have the blob data reader. There is also queue related ones like storage queue data contributor, message queue processor, message queue sender. So we can have very fine grained access permissions and roles defined using these RBAC roles. Then we have the Storage Explorer, which can be used to explore these services and the data which is stored, or the details regarding these different services. So for example, in case of the containers or the blobs, so in the storage account ADLS Gen 2, there is no blobs concept. These are called as containers, and within containers, you can create something called as a file system. So file system acts as your top level container, and then in that you can have separate folders, you can have subfolders, and you can place your files and folders inside that, or your data files inside this. So that's about the containers. Same way, if we have created file share, if we have created queues, if we have tables, we can access them using the portal itself via this Storage Explorer. Then comes the settings which are related to security. And we access these services programmatically using the access keys. Access keys is a mechanism which provides us a connection string. And using this connection string, we can use the APIs provided by different programming languages to interact with these set of storage account services. Then we can enable the geo-replication, the CORS HTTP features for cross-site scripting calls or cross-site origin. Then we also can modify some of the settings which we chose initially at the time of creating the account. This can be changed. And we can also use encryption. So by default, when we create a storage account, Microsoft uses its own managed keys to encrypt the data at rest. And we can override this by using our own customer managed key. So if your organization enforces that you control the keys which are used for encrypting the data, then you can use this option. You can bring your own key, which is also called as BYOK, and you can override the key which is used for encrypting the data at rest. We also have what is called as the shared access signature, or SAS. What the shared access signature does is it allows us to delegate the access to these services. So let's say I don't want to give full-time access to somebody to my storage account. I want to give a very limited period access. Then I can go here in the SAS access signature and shared access signature, sorry. I can choose the service for which I want to give or restrict the access. I can say what is the kind of resource, what is the kind of permission. So let's say I want to give only read permission and then list permission. These are the only two permissions I want to give at the blob level. And then I can set the time. I can say this is, let's say, starting from tomorrow, and then I can say for 1 week. And I can also choose whether it can be accessed only using HTTPS or both over HTTP and HTTPS, and which key from my 2 access keys that I want to use. And once I do this, I can generate a connection string, which can be shared with the person who is going to use that delegated access. And this will be available. The resource will be accessible to that person only for this duration of the time. Next feature of storage account is the firewalls and virtual networks. So right now, if you remember, initially when I created the storage account, I chose all networks. So that means this can be accessed from anywhere, but I can restrict this, and I can say I have a virtual network VNet created within my subscription. I want to restrict access to the services to a specific IP range or to a specific virtual network. So I can give the CIDR address here. I can say if I want to exempt any of the Microsoft trusted services from this exception. And that allows me to build more security around how people access my storage account. Similar thing is with the private link. So we can create a private link between multiple services, which will allow other services to connect privately to the storage account. And then we also have the advanced security, which is the threat protection. So this can also be enabled. And in the properties here, we can see that, let me just enable the mask. So close your eyes when it comes to these subscription keys. What happens is there are multiple services or multiple endpoints which are exposed based on the type of the service. So if it's a blob service, we can see that it is exposed using this blob.core.windows.net endpoint. If it's a file service, it gets exposed using this different endpoints. The queue service has its own endpoint, and this allows, again, the REST APIs or other SDKs to communicate with this storage account. So with that, let me quickly toggle the mask. And those were all the properties or the settings at the general storage account level. Then we have specific settings at the service level. So Data Lake Storage has its own settings for containers, data protection, lifecycle management. So here again, we can enable things like when it comes to the Data Lake Storage or the containers itself, whether we want to have that soft delete feature, the versioning. We can also enable lifecycle management. So we can add rules to say if, let's say, there is a blob or a folder which is currently in the cold tier, that is currently in the hot tier. That means I'm accessing it quite frequently, but over a period of time, let's say our business processing is such that after 1 month or after 2 months, I don't need that data to be frequently accessed. Then I can define a rule to say this particular blob, if it has not been modified for X number of days, it can be moved to a cool storage tier. So this will help me to reduce my overall cost. Same thing for moving from the cool storage to the archive storage. And we can also define if a blob or if a file needs to be deleted after a period of time. So let me just close this. And similarly, we have settings for other services like the file shares, the soft deletes for file shares, tables and queues. And then we have the monitoring options. So this part, the support, troubleshooting, monitoring, this is common to most of the Azure services when it comes to the control plane or the management plane. So we can use application insights to monitor the state of our storage account. We can see how many transactions are running, what is the capacity of the storage account that has been used so far. This is the default template. I can also change this to have a different time range, and I can get these built-in metrics. If I'm not happy with that, I can build my own metrics. So I can create custom dashboards and I can select the type of metrics and I can look at these different statistics and the different usage patterns for the different services. And then the last part is support. So this is the management part, as I said. This is where we will control. So typically, if you have administrator kind of person who manages your storage needs, he will be the one who will be using this. Once this is all set up, how do we interact with this? How do we upload files? How do we download files? If you want to do everything using browser-based features, then there is a Storage Explorer preview, which I showed earlier. So we can use this to download, upload, to create new folders, to manage access, and to view properties and all. The other option is to use a client tool like Microsoft Azure Storage Explorer. So this allows us to log into our subscription, and then we can access the same what we see on the portal using this client-side tool. So I can do same kind of things. I can work with uploads, downloads, and the similar features like managing the access, and all other features are available via this client tool. The third way is using your scripting or the APIs or SDKs which are provided. So here I'm going to use the AZCLI, the cross-platform Azure command line tool, and let me fire this command, which is related to the storage of containers, and let me list the containers that I have. So you can see that I have this COVID data and analysis as two of the file system or two containers which are on my SQL PASS storage account. And I can also change the type here. Currently, I'm showing this as table, but if I don't want a tabular output, then one of the good feature of AZCLI is you can get color coded JSON. If you don't want to use AZCLI, if you come from a PowerShell background, then you also have the option of using PowerShell. So you can use the PowerShell modules, which again allow you to interact with the Azure services, not just the storage account. All the other services are also accessible using the Azure PowerShell modules. The next one is the programmatic access. So let me show you quickly how we can interact using the SDKs. And for that, let me go and create a queue, for example. And if I go into the queues, or let me go here. Let me create a new queue, and I will populate some messages into this queue from a .NET Core program. So I want to create a queue called JSQ items. And here I have created the queue, and you can see that there are no queue messages, or there are no messages available here. What I can do is I can go back into my storage account. I can take this access key which was available. So I can choose either the first one or the second one, any one of these access keys, and then use the packages. So at the top level, Microsoft Azure Storage Common Package is for the complete storage account access, and the specific one for queue is storage queue. I include these two packages in my solution or program, and then I use that connection string. I specify the connection string, and then I can create the number of messages. I can populate that queue with X number of messages. The default is 5000, but if I go here and I say .NET run, and let's say I create 100 messages. So this one will go and start populating the messages in the queue. And if we go back into the queues, if I look at the queues, you can see that now programmatically I have populated the queue messages. So this is the different ways in which we can interact with these services. So I showed you just the queue part, but all the other services like the table and the other APIs or the file services, the data lake storage, they all have these kind of capabilities that we can interact with them programmatically. The next one in the services that we are going to use in building the modern data warehouse is what is called as a data factory. So we looked at the different services which are required or different phases using which we populate the data or we transition the data, right? And for the purpose of integrating data from different sources, we use what is called as Azure Data Factory. Azure Data Factory is your service which allows integration. It's a cloud integration tool. So if we've used anything in the past like SSIS, this is equivalent of that, but on the cloud. We don't use any client tools. We use the browser to provision this service, and creating a service for Data Factory is exactly similar to creating the storage account. So we start with Data Factory. The options in terms of creating Data Factory is quite small, or the parameters that it takes. So I will provide what is the resource group name, the region name, and which version. So the latest version of Data Factory is V2. And if you're creating a new one, I recommend that you choose V2. We also have Git integration, and currently Azure DevOps and GitHub are the two options which are supported out of the box. I can say I don't want to configure the source control right now. I can configure Git later, and that's all. I can provide the tags, review and create, and you can go ahead and create the Data Factory. I have, again, in the interest of time, gone ahead and created this Data Factory instance. So let's go into Data Factory. It is similar. On the left hand side, you have the control plane or the management pane, which allows the administrator to control the access. And for the developers, it is this author and monitor pane. So this is what we will use to build our Data Factory pipelines. When we log into the Data Factory, we get this nice UI. And to start with, we can go through quick starts, like creating a pipeline. How do we create data flow? How do we create, how do we copy a data? But let me go and quickly walk you through the initial parts. So if I go into this author section here, this is where we get a canvas, and this is where we build all the features that we need for our pipelines. So Data Factory has this concept of pipelines, data sets, data flows, and we also get the monitoring UI and the integration part or management part. And the first thing that we do is creating of what is called as the link service. Link service is your connection to something, to a data source. In order to bring in data or to send data somewhere, we need to establish connection to that from the Data Factory. And Data Factory by default has all these different connectors. So if we scroll down, I think there are more than 100 connectors, and these are organized into the native Azure services that it supports. Data Lake, we have the database services, we have the Key Vault, Synapse, table storage, all this is supported. We have the traditional databases as well as cloud databases like the Redshift, Impala. We have the SQL, NoSQL kind of databases. There is Hive, Access, things like Presto, Spark, Teradata, all this is supported. We have different types of files which can be worked with. Then we also have generic protocols. There is support for NoSQL, and there is support for these SaaS platforms as well, like SAP, Salesforce, Zoho. So this becomes your truly like a hybrid data connector or data orchestrating tool. You can connect to cloud services, you can connect to on-premise services, you can connect to SaaS services. It is all supported using these connections, which are called as linked services. So I have created some linked services for the purpose of this demo. So let's start by looking at the first one. So I want to connect my data factory instance to the data lake storage that I have created. And here you can see that when I click on new and I say, let's say data lake storage connection I want to create, it will ask me these details. What is the name of my connection or the linked service? I need to provide some description, and Data Factory has this concept of integration runtime. So think of integration runtime as the execution engine or something that will trigger your pipelines. There are three types of integration runtimes which is supported by Data Factory. By default, it supports what is called as auto reservoir integration runtime. This is what we are seeing currently. And this is used when everything is in the cloud. So let's say your source is in the cloud, your target where you are going to write the data is also in the cloud. The auto reservoir integration runtime is a better option. But if you want to connect to on-premise sources, then you can create what is called as a self-hosted runtime. So this allows us to install a runtime on either an on-premise virtual machine or a virtual machine in the cloud. And then we can set the restrictions. We can have all those firewall rules and things like that set up on this self-hosted IR. So this is specifically used when we want to run activities on-premise or on a private network. And there is also third one, which is specifically for the SSIS. SSIS has been around for quite a long time. And if you have SSIS packages, if you look at all the services right now, when we talk about cloud, you see that SQL Server has its equivalents on the cloud, like Azure SQL Database. There is the hyperscale and all those different options if you want to migrate to cloud. But there is no easy option for SSIS. If you have developed SSIS packages over a period of time and you want to run them on cloud, then you can create a runtime which is specifically for running SSIS packages. That is called as SSIS IR. Once we select the type of runtime or the execution engine that we want to execute our jobs, the next thing is how do we want to connect? What is the authentication method to connect to that runtime? So since I'm connecting to the data lake storage, I have the option of using the account key, which I used when connecting to that the queue. There is also this concept of service principal. So I can create identity in Azure Active Directory, and I can have a principal associated with that identity, and I can use that service principal to access. I can grant permission to that service principal to the storage account, and I can use that service principal. And the third one is managed identity. Managed identity is like advanced version of service principal. So when we create the service, there are some services in Azure which have a special identity assigned to them, and that is called as managed identity. And this identity lives and dies with your service. What this allows us to do is use this managed identity to integrate with other services which support managed identity. And in my opinion, this is the most secure method. If your service supports managed identity, please go ahead and use managed identity, because you don't have to exchange any username, password, anything like that. This makes your communication or integration between different services very, very secure. And then we choose like which is the account that I want to connect. So in this case, I will just fill in the details and I get the account where I want to connect to. And then I can test this connection. If everything is fine, my connection should be successful. This is for the storage account. Same way, in this example, what I'm going to do is I'm going to bring in some data which is related to the COVID-19. This is a public data set which is available and which is published by the European Center for Disease Prevention and Control. It's available on their GitHub page. So I'm going to bring in this data. If you want to see what are the details of this data, you can go through this GitHub page. I'll share the link later in the references. So this has got about 40 different attributes, like what is the country code, continent, location, date, total number of cases, and so on and so forth, related to the figures which are published by different countries. And I will connect to that using HTTP. So this is again a type of service or the linked service which is available, and I need to specify again which integration runtime, what is the base URL, and what is the authentication type. So what you see here is based on the type of your connection, these options would vary. So let me show you another example where if I want to connect, let's say, to a database, and let's choose Postgres, for example. If I want to connect to a Postgres database, you would see that the options here or the parameters, they would vary. So I would be asked to provide the server name, port, database, username, the password, encryption method, and these kind of things which are very specific to that connection. And similarly, I have here another connection which is created to the same GitHub source, but this one is using web. Sorry, the second one is using REST. So this returns only the JSON data. And going back to the data set here, this data set which is published, it's available in 3 different formats. So you have CSV data, you have JSON data, and you have XLSX data. It's the same data represented in different forms. So what I'm trying to do here is using the first one, I want to get the CSV data, first link service, and the second one, the REST one, I want to use the JSON connection. So think of link service as the connection to your source. It's like a database connection. Once you have this connection established, the next thing we need is the data set. So this is like if you are connecting, if you have established a connection to your SQL database, which table you want to work with and which data in that table you want to work with. So in the data set, you define which is the link service you are going to use and what is the type of data you want to bring in. So here, the relative data that I want to bring using this REST service is the JSON data. And then I can provide some additional parameters. Similarly, I have for the CSV data, you can see that based on the type of my source, again, all these options, they vary. So when it comes to CSV, we have different parameters or different options to choose the column delimiter, row delimiter. I can say if my first row has a header and things like that. Now I have built the connection and the type of data. How do I use this data? So for that, we need to make use of this data or the data set somewhere. And that is where the pipelines come into the picture. So in pipeline, this data factory provides us different options. So I can say I want to use copy data. I want to use a Dataflow. I want to connect to Azure Data Explorer, or if I want to connect to HD Insight, if I want to do some looping. So the example that I'm showing here is a very simple copy activity. So what I want to do is I want to copy the CSV data from that GitHub and I want to store it in my data lake storage. So the source here is that data set, which is pointing to my CSV data. And the sink is I create the same way a data set for storing my data. And this is pointing to my data lake storage now. And once I have this pipeline, once I define what needs to be done, I can trigger it. I can say trigger it right now. And it will start to copy the data. It will pull the data from that GitHub URL and it will push it into my ADLS storage. So I can go back into the storage account. And if I look at the container, this is where I'm going to store the CSV data. And you can see that this is the file which got pulled in just now, 755. And what I've done is I've given a dynamic name here saying I want this COVID data and then the timestamp. date and the month and the year. So for that, let me quickly show you in the data set how we can do that. So in the source data set, when I look at this, copy data. You can see that we can add dynamic parameters here. So this is my target location where I'm storing the data. I can specify if I want to create some subfolders here, and I can also add dynamic properties. So I can add functions, I can add datetime function, I can add string functions. And what I'm doing here is I'm specifying a static part of the file name, and then I format the current date in this. And this is how I build a dynamic name for my file. So even though my source has a very static name, I'm making it dynamic by adding these kind of parameters or variables. And these kind of parameters, they can be defined at various levels. So that is how we build the pipeline. So we started with the connection linked service. Then we started with data set, what source and what is the sync we want to have. And then we trigger those actions using the pipeline. So pipeline is the one which is actually doing some transformation. The other thing we can do with Data Factory. So copy is very simple. We can do this copy using, where is my mouse? Yeah. We can copy data from SQL Server. We can copy data from any of those linked services that I showed earlier. I would just need 5 more minutes, Pio, if you don't mind.
Okay, I was just about to message
you. Yeah, yeah. I will just quickly finish this, but looks like there is some problem with my mouse. I'm not able to move it to the right location. Come on. Okay. Next thing we have in Data Factory is data flows. So what data flows allows us to do is a no code scenario. We can use this canvas again and build workflow or build data processing. So here I can start with, let's say I want to do analysis on the data that I brought in. I want to say do some analysis in terms of let's say which are the countries where there are more than 5,000 cases or 500 cases, and I want to do some sorting, I want to do some filtering. So in this case, I can use this data flow concept to work with the data. So I start with the source. Again, the concept is similar. I choose where is my source option. So this is the data source from where I want to bring in the data. So it is, again, we choose the same input data sets, and we have different options based on the type of activity. So I can use this to infer the schema. And here you can see that in my input data source, I've got 40 columns. Then I can do filtering or I can do projection. And I can say I don't need all the 40 columns from my input. For my analysis, I need to select only 23 columns. So it's like instead of doing select star, I can specify which columns I need. Then I can do filtering. So the filter that I've specified here is to say total number of cases which are greater than 500. Once I have those cases, I can go into sorting. So all this is possible, whatever I'm showing you, using these options. And if you understand basic concepts like what is a join, how to do exist, how to do lookup, how to do union, how to do derived column, if you want some aggregates, if you want to have you want to flatten the data, you want to filter, sort, all these operations are available for you. And based on your kind of activity, again, the options that you see below would vary. So what I've done here is I've filtered, I've sorted the results, and then I'm writing it to, again, CSV data. So let me show you the final output in the interest of time again. This process takes about 5 minutes. So I've created another file system here, and I've created CSV and Parquet as the output here, and the output of that analysis gets written in these two folders. So what I'm able to do is, using the same data, I can fan out and I can write it in different formats. So I'm writing it in comma separated or textual format as CSV output, and the same output I'm also writing it in columnar format. So if you want, we can again redirect this output into RDBMS or any other location as well. That's possible. So the other thing that I want to quickly show is the monitoring part. In Data Factory, Data Factory is not just the integration tool, it also gives you orchestration capabilities. So you can build, you can have a look at the dashboard, you can see what are the pipeline runs within those pipelines, what were the triggers, you can filter based on the time, and you can also schedule. So what I showed you is the instant trigger, but if you want, you can say, I want to schedule a trigger, and then you can choose the trigger type, and you can build a schedule to run this on a schedule basis, like every day, every 2 hours, every 6 hours, whatever is the schedule, you can schedule that using Data Factory. So let me go back to the presentation and resume where we left. I would cover this in the next part, saying how do we measure what was the consumption. Then we looked at this mapping data flows. We can also build a very complex one. You can see a small part here. Again, I can cover that in the next session. And we looked at the monitoring options. So in summary, what we looked at today is the Azure Data Lake Storage, which gives us the petabyte scale storage, which has the hierarchical namespace. This is Hadoop compatible. And if we are using Gen 2 version, there is actually a driver which is called as ABFS driver. I recommend that you use this for performance reasons. Some of the best practices includes using service principals and managed identities. Instead of using individual groups or individual user accounts, use security groups and use the security features for firewalls. For the Data Factory, the main features to remember is it's the cloud ETL service. You can connect to almost any kind of data source, and this gives you a scale out serverless data integration and data transformation capability. We saw how we can do code-free UI using the Dataflow capabilities. It also has monitoring and management. The main components to remember is the linked services, datasets, pipelines, and triggers, and also the integration runtimes. There are three, which is the auto-resolver, self-hosted, and SSIS. So I've given some references here for the services that I used and things that I showed during the demo. If you want to learn more about the data lake storage, there is a MS Learn path, learning path, which you can find here. And thank you. Thanks a lot for attending this session. I'm sorry it just overran by 4 minutes or 5 minutes. In case you have joined late and you want to connect with me, these are again the different options or different ways in which you can connect with me. Thanks a lot.
Yeah, awesome. Yeah, so guys, if you have any questions, if you haven't, because I'm looking at the chat, there's only one question. If you have any further questions to Nilesh, take note of it, and then we can discuss it next on the next session, because this is like what we said earlier. This is a 3-part series. So just take note of your session, then we can discuss it later. There's only one question on the chat right now. When you do lifecycle management, does the URL change for the files?
Does the URL change for the file? It would move from one location to another. So the base location would be same, but the zone would move from one location to another. So from your hot tier, when you move it to, let's say, cold or archive tier, you would have a different location. So the final URL would change, but the base storage account location itself would remain the same.
All right, sure. Yeah, so thank you very much, Nilesh. We'll pick it up next week, next session.
Yeah.
Thanks, Nilesh.
Thank you, guys. Yeah.
So our next, let me just turn off recording. So before I turn off recording, if you are in the Facebook or the YouTube live stream, make sure that you move and join us on Teams, because we won't be recording the next part. With that, let me just turn off the recording.